Hi, welcome to video 8.7a, Indeterminate Forms and L'Hopital's Rule. So, as you remember, I taught you L'Hopital's Rule last year. It's actually now part of the AB curriculum as of this year again. It used to be, and then it was gone, now it's back. So, L'Hopital's Rule is a very important rule, but it can only be used in certain very special cases. If you have a limit of a fraction, and when you do substitution, if you get 0 over 0 or an infinity over an infinity, then you have the right to use L'Hopital's rule, which says that that limit is going to equal the limit of the derivative of the numerator over the derivative of the denominator. Now do be careful, we're not talking about the derivative of the fraction, which would be the quotient rule. We're actually talking what people wish the quotient rule was, which was just take the derivative of the top over the derivative of the bottom. You cannot use L'Hopital's rule until you have shown the corrector that substitution yielded either 0 over 0 or an infinity over an infinity. So you must show the steps, and you also have to let me know you're using L'Hopital's, and you can certainly write LOPs, okay? But be careful, this is not the quotient rule. So here's out of the book, numbers 5 through 10. They're actually asking you to do it two ways. Use the techniques from chapters 1 and 3, and then use L'Hopital's rule. So you'll start any of these by finding the limit by substitution. So if I do the first one, number 6, I don't know why I have B and A. I have, oh, right, B and A. So I'm going to do it with L'Hopital's first. So here's number 6. First of all, you substitute. Sure enough, we get 0 over 0, which allows us to use L'Hopital's. The derivative of the numerator is 4x minus 1. Derivative of the denominator is 1. And now you replace your x by negative 1. Your answer is negative 5. The old-fashioned way of doing it, which is how we did it last year before we learned L'Hopital's, is you plug it in, you get 0 over 0. You factor. And remember, if you plugged in negative 1 and got 0 on the top, it had to have had a factor of x plus 1. Those factors cancel. You substitute, you'll notice you get the exact same answer. When we're in this whole section and we're dealing with limits, when they talk about exponential and logarithmic functions, it would just help you to actually know those actual functions. So if you're looking at the graph of y equals e to the x, obviously the limit as x goes to infinity of e to the x is infinity. The limit as x approaches negative infinity of e to the x is obviously visually 0. The graph of y equals ln x, which has a vertical asymptote at the y-axis. The limit as x approaches infinity is approaching infinity because it is slowly rising, but it will rise forever. The limit as x approaches 0 from the right of this function is negative infinity. Now, if you were asked from the left, of course, from the left, there's absolutely nothing going on at all because there's no graph there, and therefore the two-sided limit would also not exist. All right, so now we're looking at something like number 18. So for numbers 11 to 44, evaluate the limit using L'Hopital's rule if necessary. So they are letting you know that they prefer you use L'Hopital's rule over something else. So here's an example. So it's a limit. We substitute. We get e to the 0 is 1 minus 1 plus 0, which gives 0 over 0 cubed, which is 0. Now here, unlike in the other one we just did, you have no other options. You get 0 over 0. You can't factor. You can't rationalize. And you can't simplify. There's nothing you can do with this. So L'Hopital's is the way to go. So the derivative of e to the x is e to the x. The derivative minus parentheses, derivative of 1 is 0, derivative of 1x is 1, derivative of x cubed is 3x squared. Don't forget this is still a limit. From there, you will simplify. That'll be e to the x minus 1 over 3x squared. You'll substitute again. Once again, you'll get 0 over 0. So you end up using L'Hopital's repeatedly. Now, so I'm going to use L'Hopital's again. Notice how I write it above the equal sign that I got 0 over 0, and underneath I write L'Hopital's. So now I'm going to take the derivative of the top, which is e to the x minus 0 over 6x. This time, I do not get 0 over 0 anymore, because when I plug 0 into the top this time, I get e to the 0 is 1. The denominator is 6 times 0, which is 0. I get a non-zero over 0, which you and I know means I have either infinity or negative infinity as an answer. The way to find out, well, the numerator is positive 1. The denominator is 0, but remember it's the limit as x approaches 0 from the right. So on the bottom you have 6, which is positive, times x, which is approaching 0 from the right side, which is through positives, and therefore I end up with a positive over 0 through positive, which will give us positive infinity. Here's another, this is the actual number 18. This was like number 18. It was over x cubed, and this is x to the n. This is limit as x approaches 0 from the right. So once again, I plug it in. 0 to any power will be 0, except for 0 to the 0, but we're assuming, oh, plus it says n is a positive integer bigger than 2. Okay, so we substitute. We get 0 over 0, which allows us to use L'Hopital's. So you take the derivative of the numerator, so which is e to the x minus parentheses 0 plus 1, so e to the x minus 1. Now on the bottom, you're taking the derivative of x to the n, where n is a positive integer. The exponent comes in front, and then you subtract 1 from the exponent. When I substitute x equals 0, I'll get e to the 0's 1 minus 1 is 0, and then I have 0 times x to the negative 1, which is still going to be 0. I get to use L'Hopital's again. Derivative of this numerator is e to the x. Derivative of this is n times. The derivative of x to the n minus 1 is n minus 1 times x to the n minus 2. This time I won't get 0 over 0. I'll plug in x equals 0. I'll get 1 over 0, which is a non-zero over 0, which tells me it's infinity or negative infinity. The numerator is positive 1. And what's happening is I'm approaching 0 from the right side. So what happens is n is a constant, n minus 1 is a constant, and these are positive integers, greater than 2. So what happens is all I have is my x here is approaching 0 from the right to a power of n minus 2. So that'll be approaching 0 from the right, and a positive over a positive will give me positive infinity. Number 32, a little bit more complicated. So you plug in infinity. So infinity squared means infinity times infinity, which is infinity. Then you plug infinity in here, you get infinity squared, which is infinity, plus 1, which is infinity. Square root of infinity is infinity. So I do get infinity over infinity, which means I get to use L'Hopital's. And by the way, we haven't seen infinity over infinity before. It's not the case where you would try and factor or rationalize anyways. So that's when you get 0, 0. So we're going to take the derivative of the top is 2x. This is actually x squared plus 1 to the half. So the derivative of that is 1 half x squared plus 1 to the negative a half times 2x. The 2's cancel. The x's cancel. You're left with the 2 up here, and this is over x squared plus 1 to the negative x, which means it comes up on top and becomes x squared plus 1 to the positive x. You're then going to replace x by infinity. Infinity squared is infinity, plus 1 is infinity, square root of infinity is infinity, and 2 times infinity is infinity.